Okay, hello everyone. Good news. This is the last lesson of trimester 1.1. Today we'll take a look at generating quadratic regression models. Um, these type of models are used in the real world all the time. When I worked at 3M, I used this a lot. So it's kind of important. Not that what we've learned so far isn't important, but I can tell you from experience that this is used quite a lot in industry. So our objective today is to use a quadratic regression model to estimate data. So I've always liked this lesson. It's kind of a fun lesson, and it's something that I can generally relate to. So here we have an example, a quadratic regression model. And we have this baseball player. Now, someone has gone out and collected data on a baseball player. In this data, the table right shows a horizontal distance in feet traveled by a baseball hit at various angles. The initial speed of the ball at the bat is constant, batter up. So you're probably thinking, well, gee, how could they keep the speed of a ball constant? Well, I mean, you can throw it from a machine, right? And then, and I'm sure you've probably seen these machines like in golf when they're testing out clubs and so on and so forth. And so you can adjust the angle but keep the speeds constant. So, I mean, so this can be done. But anyway, this data here was collected, and it shows the feet the baseball traveled at various angles in which the bat was hit. The ball was hit, I'm sorry, or at which angle the bat was swung. So imagine that the bat comes around the batter's waist belly high, so that would be like an angle of 0 degrees. And then if the bat was right up by his head, then that would be like 90 degrees, right? So here we see that these various angles and various feet. Now, the distance the ball travels is a function of the angle at which the bat was swung. So the angle is the independent variable, and we always give that the value of the variable x. So we'll say x1, and then the distance is, we'll say y1. So distance depends on feet. So what we want to do, we want to generate a quadratic regression model based upon that data. So a model and like f of x equals ax squared plus bx plus c. And what this model will give us, it will give us the parameters for A, B, and C. So let's do that. I am going to go out to decimals, and I will generate a regression model, quadratic regression model, and I'll show you how to do that. So pay close attention, because you will have a take-home test on this, and it's quite easy. So, and again, this is a fun lesson. I like it. So let's see here. So what I need to do, you see that plus button there? I am going to press that plus button, and then I will select the table. And then I am going to enter in, if I go back here, my x1 values, degrees or angle, and my y1 values. So let me do that. Okay, so the first one, so 10, 15, 20, 24, 30, and I'm just pressing the enter key each time I enter in the value, and it just cursors down. 40, 45, 48, 50, 58, 60, and 64. So that was my angle. Okay, x1. Now I need to enter in my feet. So go back up top. So that was 115.6, and then 157.2, and 189.2, 220.8, 253.8, 269.2, 284.8, 285.0, 277.4, 269.2, 244.2, 231.4, and I am done. 180.4. So I entered in all the data, x1 and y1. Now what? Okay, so I'll go back here. And as I said, I want to generate a quadratic regression model, ax squared plus bx plus c. So we develop a quadratic regression models to represent the data. So let's do that. All I did was enter in the data. I need to actually generate the regression model. Well, I want you to notice here, Desmos has plotted those points, so that was pretty cool. You see it plotted those points there. All right, so what we do to generate that model, I need to press plus again, and then you want to press f of x expression. And now I want you to notice up here we have x1 and y1, so those are the variable names we're going to have to use when we generate our equation. So down here, I'll say y1, but then I am going to use the tilde key, which is on the left side of my keyboard, right below the escape key. It's on the left side of my keyboard. A little squirrely thing. So that's the tilde. Okay, and then I'll type in a x1 and then caret key, raise the second, and then move my arrow over, plus bx1 plus c. Now I want you to notice that I used x1 and y1 in that expression because those are the same variables in the table. Don't just enter y and x. You can't do that. You have to enter those the same variables that you see in the table. So y, so there's, all right, now I want you to notice what I got here, okay? I want you to notice, so this generated my parameters, okay? So let me go back here now because I've already done this. So what that did, it generated that equation right there. Well, it doesn't look like an equation to you, but I know what it is. And so if I look here, so I can see my a, again, I can see my a value, my b value, and my c value. All right. So my quadratic regression equation is going to be y equals, what was that, negative 0.173 x squared, because that's a, and then plus 4.52x, and then minus 21.90. So that was my equation. Now if I go back to Desmos, I want you to notice that it was cool enough that it actually generated that parabola based upon that equation. So that was pretty cool. What was the vertex there they gave me? Oh, 41.7. Right? So it actually generated that equation. Now, there's some other information in here. Very helpful information. And I want you to notice this r squared value. What is r squared? Well, after we generate our equation, which is what we did, the next step is to determine if the model is a good representation of the data. We say a good fit. It has to be a good representation. If it's a poor representation, who would want to use a model that does a poor job in estimating something? Well, how do you determine if it's a good model? Well, we have this thing called r squared. And r squared indicates a good fit. A r squared value of 1 would indicate a perfect fit. Okay, I want you to notice that we have an r squared value. R squared is equal to 0.9812. Very good fit. Excellent fit. Okay, excellent fit there. So if the model represents a good fit, a r squared value of 0.8 or greater, we can use the model to make predictions. Now, why did I choose 0.8? Well, I just know I'm working at 3M. If we got something 0.8 or greater, then we were pretty happy about it. It was a very reliable model. Actually, our cutoff value was like 0.7. But if it was 0.8, we didn't have many questions. If it was 0.9, we were really, really happy. Okay, so estimate, now with that there, we could estimate the distance a baseball will travel if we hit it at an angle of 37 degrees. So here, function notation, so f of 37 equals negative 0.173 times 37 squared, and then plus 14.52 times 37 minus 21.90. Okay, now let me go out to my calculator. Why did this keyboard come up? Oh, it came up there all by itself. Strange. All right, so let me minimize that, and close that out. Okay, so I've entered that in my calculator, so I'll just do that again. You know, we haven't used our calculator too much. Again, this is the negative, so that's negative 0.0173 times 37. Here's the square key. You see that x squared plus 14.52 times 37, and then minus, remember 37 was the angle that we were using to estimate the distance, minus 21.9, and we get, wait a minute, we got 49.65 feet. 49.61. Let's see here. Negative. Boy, that just seems way too high. I must have done something wrong. Oh, I did. Okay, that was negative. It was negative 0.173. I was going to say 491 feet. Okay. Boy, you really hit it out of the ballpark if you do that. Greatest baseball player ever lived. All right, so here, so let me clear that out. So this is negative 0.173 times 37 squared. But you know, that was a mistake, but that was a good mistake, because when you actually, you know, when you take your online test, boy, you really want to like make sure that things are reasonable. Okay, so times 37 squared. So that was a good mistake. Okay, and then plus 14.52 times 37, and then minus 21.9. Okay, that seems better. 278.5 feet. Okay, so this would give me 278.5 feet. Just let me verify that again. Yep, 278.5 feet. So we could say that if you hit the ball at an angle of 37 degrees, the ball will travel about 278.5 feet. So 37 degrees would be about right in here. And they said 278.5. You see how well that model fits that data? Okay, very good fit. Very good fit. All right, so to get practice with this then, and let me just go back out to Desmos. You know, if we use that model, what's the vertex? The model would say that if you hit the ball at an angle of about 42 feet, the ball will travel the farthest. Maybe your baseball coach told you that. Okay, swing at 42 feet, Jerry, Mary, whoever. Swing at 42 degrees. Or 42 degrees, I'm sorry. Swing it at 42 degrees. All right, so here. All right, so there. Now, let's take a look at this. I want you guys to do this, get some practice. Here, the table shows approximate run times for 16 millimeter films. Given the diameter of the film on the reel, find a quadratic model for the runtime given the diameter. Use the model to estimate the runtime for a reel of film with a diameter of 15 inches. So given the diameter of the film, so the diameter, that's your independent variable. And runtime, so runtime depends on the diameter. Well, that would make sense, okay? The larger the diameter of the reel, the longer the runtime should be, okay? That would make sense. So what I want you to do is review the video, go through this, because you have to get to understand how to use Desmos to generate a regression model. That's going to be required on your take-home exam. And make sure they actually did this with the calculator, but you're using Desmos. Make sure you get those values, okay? Your parameters A, B, and C, and the R squared value. when you take the take-home test, I usually give you like 3 r² values so you can check your work. Because if you enter in data right, you'll get the r² value I provide. Now, it'd be one of 3, right? So that would be a good check for you that you entered in something right. Because after all, okay, I won't be able to see your work, if you know what I mean. I won't be able to see your work, but then you'll have to use that quadratic model to make projections. So here, okay, so I want you to use the model and then estimate the runtime for a reel of film with a diameter of 15 inches. Okay, so that's it for today's lesson. One of my favorites. So review the video and then go through the example, make sure that you're getting everything right. And then you'll have some homework, and then you'll have also some review problems for your test. On Thursday, we'll start the review for your Chapter 5B test.